Hello, welcome to In 5 Minutes. The example shown here is very much similar to the example shown in the previous video, but the added thing over here, you can see the drop of the diode of 0.7 volt is considered over here. That is, the diode is not considered as the ideal diode. We are considering the diode drop as 0.7 volts. Now, in which half cycle the diode will be getting forward biased? The positive half cycle or the negative half cycle? So, when you look in the positive half cycle, you will apply positive to this terminal, negative to the other terminal, and the terminals of the diode are negative and positive. So in the positive half cycle, again the diode is reverse biased. So we are neglecting the first positive half cycle, we are going to the first negative half cycle. In this case, you are applying negative terminal of the supply over here and positive is connected over here. So when you look at the step 1, the diode is getting forward biased in the first negative half cycle, and the circuit for it will look like you have the capacitor, then the diode, which will now have the potential drop of 0.7 volts, then you have 5 volts, then the input voltage you have minus plus 20 volts, you have the capacitor C. Again, the charging of the capacitor will be negative positive because the diode is getting forward biased in the negative half cycle. So, for finding the charging path, that is charging path of the capacitor will be Vi plus Vc plus 0.7 minus 5 equals to 0. So, your capacitor will charge to Vi minus 0.7 plus 5, that will be 24.3 volts, because in the negative half cycle your Vi is minus 20 volts. So minus 20 minus 0.7 plus 5 will give you 24.3 volts. In the same half cycle, your output ke liye you will need to draw the diagram as, or you can draw in the same diagram, you will have plus minus Vo. So when you apply KVL in this loop, you will have Vo plus 0.7 volts minus 5 equals to 0. So you will get Vo as 4.3 volts. So you are getting output as 4.3 volts and your capacitor is charging to 24.3 volts in the first negative half cycle. Now our step 2 is during the next positive half cycle. What will be there in the next positive half cycle? That is, we are not considering this half cycle. We have already considered this half cycle. Now we are moving to the positive half cycle. In the positive half cycle, you will have plus here, minus here, and the diode in this case will be reverse bias. So it will be open circuited and this 5 volt will become redundant. So you will have the circuit in the positive half cycle as capacitor, then this part will be open, you have 5 volts, and here plus minus Vo, you have RL, you have plus minus Vi, and capacitor, the charge on the capacitor what we have got is 24.3 volts, and now your Vi is maximum going to 10 volts in the positive half cycle. This is your input. Now for getting the output voltage, what we can do is you apply the KVL. We applying KVL from input to the output. So the equation for the KVL will be Vi. Well, how is the direction of charging? This side negative, this side positive for the capacitor. So Vi plus Vc minus Vo equals to 0. So we are having Vo as Vi plus Vc, which will be 10 plus 24.3 volts. So we are getting it as 34.3 volts as the output. So in the next positive half cycle, your output is going to 34.3 volts. So when you look at the final output swing, you can see over here your input in the positive half cycle, we are not considering anything. So we are not getting in the first half cycle, we are not getting any output in the first half cycle. Next negative half cycle, we are getting output as 4.3 volts. After that we are getting it as 34.3 volts. So when you look at the peak to peak value of the output, again it is 30 volts. It is not changing. That is, the end to end or peak to peak value of the input and output is the same. What we are shifting is, we are just shifting the output waveform in the positive and negative half cycles.